So now let's look into another model, which is Oscar and VinVL. It's coming from tech giants, actually from Microsoft, from similar authors. So what they have is very simple. So again, you have multi-layer transformer block. At the input, you give the caption. So in this case, the image is this, yeah? Oh, okay, so a dog is sitting on the couch, yeah? So this is the image. I believe, yeah, so that's the image. A dog is sitting on the couch. So you have that. You also do the object detector. So this is CVPR 2021, I think, if I got, yeah, this is also ECCV 2021, but it came after VILT, I think. So you have the region extractor. So you have the region detector network that gives you the region. And that gives you all the three things which the object detector gives you. And you pass this object detector as your visual input. So this green part is your visual input. You have the text, and this orange part is your text input. So you tokenize the text and so on and so forth, same as in VILT. In addition to that, they have something which is called object tags. Yeah. So these are this is what the object detector is giving you. So object detector has given you two objects, dog and couch. Yeah. So this tags here is dog and cow. There are special token, for example, CLS token, separated tokens for the word. There is separated token for the tags and so on and so forth. Yeah, so that is standard. You add particular position embedding for text, particular position embedding for the object detector output, and so on and so forth. So that is also pretty standard. Now there are two views which they are mentioning. One is modality view, another is dictionary view. If you consider these tags, these object tags, which are coming from your object detector as part of your vision modality, then that's called modality view. So if that is considered as part of the vision modality, that's modality view. If you consider those object tag as part of your language modality, that's called dictionary view. Yeah, simple. And basically the core idea is, so since you are going to consider in the dictionary view these object tags as part of your language, and in the modality view you are going to consider it as part of your vision. So these object tag will serve as an anchor to align these two modalities. Yeah, good. Okay, so that is the basic idea. Okay, and what they use. So I have already explained the language view and the dictionary view and so on and so forth. So this is modality. So this is modality view, and I think this is dictionary view. So that is fine. And what you do is, again, you mask your text token, and you recover. So probability of your text token, the mask text token HI. In this case, they are representing with H. Yeah. So when you have a dictionary view, then your word and the corresponding object tags and word are together in the dictionary view. Yeah. So this is the dictionary view of. So H consists of word and the object tags. You mask randomly 15% of them and you recover them. Yeah. So that is the loss here, negative log likelihood. Mask, token, modeling. Yeah. So that's what we have covered just now in the unitar as well. Okay. And the second one is modality view. For modality view, your Q, this object tag, will become part of your visual tokens. Yeah? And what you do with that is you do contrastive learning, essentially. So what you essentially do is you find whether you build positive and negative pair, essentially. Yeah? And you do just cross entropy on positive and negative pair. Okay, and you see that the two losses have these object tags Q shared, and that is doing the trick. Okay, and then I think they train it on conceptual caption. So the data set which they have is slightly more than unitar. So that's one of the advantage, and I think the network which they have is the vision encoder network which they have is more fancier. Let me put it this way, and hence they are able to outperform unitar. So they achieve state-of-the-art results both in base and large, and they are denoting the best state-of-the-art, including unitar. Yeah. Okay. So that is Oscar. Okay. So VinVL is Oscar plus essentially. So when you are using Oscar is trained on open set data set for object detection. And what you have, as you can see here, is this is a scene, and it is giving you the surfboard, the label for the surfboard, the bounding box for the surfboard, bounding box for the boy, bounding box for the man, and so on and so forth. Okay, and it does make some error. For example, it is considering that this bounding box here is also a surfboard, so there are errors. Okay, so it is looking at some of the concept, but when you go into VinVL, they train it on a large scale data set, which is a private data set exclusive to Microsoft, and they start to detect a lot more things. Yeah. So now you can see they are detecting the boys and the attribute of the boy. Yeah. Man and attribute of the man. Shorts and, for example, knee length shorts, black knee length short, surfboard, and so on and so forth, wavy sea, mountain, sand. So they are trying to detect many more objects. And they are trying to provide the attributes of those objects as well. For example, colors, shape, and so on and so forth, okay, or state. So this is what VinVL is, and the backbone is the same as Oscar essentially, yeah, or as Unitar, if you like, yeah. Okay, and when they came, they became state of the art as well. But the improvement were marginal, yeah. So the improvement corresponding to Oscar is not that high, yeah. So you can see the improvement. So this is retrieval result. So you have text to, so you have visual question answering. You have image to text retrieval, which is giving you the top. So when you do matching, you do ranking. The first result, whether it is correct or not. So you can see that around 60% of the time the top result is the correct one between image to text and so on and so forth. And there is a slightly relaxed measure. For example, when you are looking at, if the positive image is in top 5, then you go with rank 5 and rank 10 and so on and so forth. You have bunch of tasks. You have question answering, you have general question answering, you have image captioning, description of image. In this case, you should focus on this CIDR score. I will not go into detail of that, higher the better. So they are getting 140.9. So the Oscar was getting around 140. Yeah. So human are higher than that, much higher than that. Yeah. So and so on and so forth. So natural language for visual reasoning as well. So there are a bunch of tasks, and they are performing very decently. And these Unitar and Oscar and VinVL, around 4 years ago, 5 years ago, they started to outperform the other methods, which were basically working with CNN and LSTM and so on and so forth, with very decent margin. So let's recap what is going on. So basically, we take the images, we apply object detector, because by that time we didn't have the mechanism to pass the patches and so on and so forth. We take the language, we tokenize the language, and then we pass them through a shared modality encoder, and we do our losses, and we do our downstream task. Good. Now there is a problem. If you look at this dog, there is a red bounding box for the dog. Hopefully it will not flicker. Okay, so you can see the dog clearly. But you can see that a dog bounding box has a lot of other stuff. For example, the dog bounding box has this couch, it has the floor, it has other stuff too. Yeah. And similarly, the couch bounding box, which is in yellow, so you can see this bounding box is actually containing more of the dog than the couch. Yeah. So so this is a little bit of an issue with this network, with this kind of object detector network. You can choose, you can fix that problem by providing segmentation. Yeah. But the ground truth for segmentation, so it costs, for example, if you are providing label, it's probably 1 or 2 cents per image. As soon as you start to provide bounding boxes for objects, it start to go higher, like 10-20 cents per image. And if you are asking for segmentation mask, you are talking about $2 per image. And that is if you have 1 or 2 objects to segment. If you have 20 objects, 30 objects to segment or more, then the money is more. Yeah. So even the tech giants couldn't afford that. Yeah. Or maybe they could afford that, but they didn't think of, because this is crazy. Yeah. You are defining segmentation for millions of samples for all the objects which are there. That's too much. Yeah. So people didn't go down that route, thankfully. Yeah. So